Have you ever wondered why something like ball floats, meanwhile other stuff like rock sinks? Generally, we can determine something float by determining its weight. Usually, something light is able to float. If it is heavy, it will sink. But the idea becomes shaky when something that is really heavy is able to float. Well, this phenomenon can be explained by the scientific principle called buoyancy. What is buoyancy? Basically, it is the ability of something to float or rise in fluid. Scientifically, it is a force that arises from pressure exerted on an object by fluid. Well, since it is a force, we call it buoyant force. The other method, we can determine the object will float by using density. Density is the amount of stuff or mass compared to its volume or its size. For an example, a box filled with stuff is heavier compared to an empty box, meaning that the box filled with stuff has higher density compared to an empty box. Another example, part of an iceberg floats in water, and the other part of iceberg sinks. Since water have a density of 1000 kg per meter cube, and the total volume of iceberg submerged in water is 90% of its total volume, we can conclude that the density of the iceberg is less than water, which means 90% of water density is equivalent to iceberg. So, the density of an iceberg is 900 kg per meter cube. Back to the ship problem. Even though a ship is very heavy, but it is also very large. Most of the ships full of hollow, so it is not dense as you might think. Because of this, ship's tanks are less than water, causing it to float. All these facts were discovered by Archimedes. Well, he was a mathematician in ancient Greece. He figured out that the buoyant force is equivalent to the weight of water displaced. For an example, a container filled up with water. After you add stuff like a ball, the water will rise. The volume of water rise is equivalent to the volume of ball submerged into water. And also, the weight of water displaced by a ball is the same as the weight of the ball. Now, let's take a look at an experiment made by our team.
Good evening, everyone. We from Fluid Squad are going to conduct an experiment about buoyancy. Before that, I would like to introduce myself. My name is Kumaravalu, son of Balaraju, from Section 1.
And I, Suraj, son of Gunasegaran from Section 1.
And I'm Thorai Singham, son of Raman from Section 2.
Okay, now I'm going to conduct an experiment about stability, where all the marbles are put at the center of the box. As you can see, as all the marbles are already put in the middle of the box does not sink because the center of gravity is aligned at the center of buoyancy, and we must always remember the center of buoyancy is always at the center of the box.
Hi guys, next we are going to conduct the other condition, which is the marble will be added to the one side of the box. The marble is added gradually one side of the box. Next, as you all can see that the box is still floating. This is because the buoyancy is greater than the weight of the box. As more marble is added to the box, the center of gravity of the box is at one side, which is not aligned to the center of buoyancy. Eventually, the box will tilt. But the box is still floating because the restoring moment due to the meta center is above to the center of gravity. Now the box is fully sink. This is because the meta center is below the center of gravity. This will cause a overturning effect rather than a restoring moment. As you all can see, the box is fully sink. Let me explain to you about center of gravity. Center of gravity consists of two parts, which is symmetrical shape and non-symmetrical shape. Symmetrical shape is when the center of gravity will be always at the center of the object. So let me move on to the next. For non-symmetrical shape consists of few shapes. To find out the center of gravity of the non-symmetrical shape, we must Total the sum of moment over the total weight.
Today I want to tell you guys about the metacenter and metacentric height. What is metacenter? Metacenter is the point of intersection of the line of action of buoyancy force before and after rotation. Okay, come, let's check the first condition, which is metacenter above the center of gravity. When the metacenter is above the center of gravity, it will cause the restoring moment which makes the boat stable. Okay, second condition, when the metacenter is below the center of gravity, it will cause overturning moment rather than restoring moment which makes the boat unstable. Okay, what is metacentric height? Metacentric height is the distance between metacenter to the center of gravity. The higher the metacentric height, the more stable the floating body. Thank you.
Explaining about stability. Firstly, the first condition is stable. When disturbance is applied, the object will move upward and then return to its original form. This is the stable condition. For the second condition is naturally stable. When disturbance are applied to the left, the object will move to the left, and this is known as naturally stable. And lastly, known as the unstable condition, when the force are applied here, the object will move downwards, and this is known as unstable condition. Thank you.
Before making a calculation, you should list all the variables given first for the still water and for the hollow box of steel. Next, you can calculate how deep is the box submerged into water, starting without put any human inside it. Since both sides have gravity, we can cancel it on both sides. So, we can get the height of the steel submerged, that is 0.2 meter. Then, we assume the thickness of the hollow steel. Outer size of the box is deducted by the volume inside of the box, and then we can get the volume of the steel. After getting volume of steel, apparent density can be calculated. Next, we put 30 people inside the box. The height of the water displaced is now changed due to the additional weight. Now, we want to calculate the stability of the box, whether the box is stable or not. So, we can use this formula. If we get more than 0, that means it is stable. Yeah, it is stable. We are using the same formula to calculate the maximum people that we can fit inside the box without sink. So, the maximum person we can put into the box is 283%. That is out of expectation. Well guys, thanks for watching. Hope you enjoy and learn something in our video. Bye!